Today's warm-up deals with proper rules surrounding dating. The half plus 7 rule says you shouldn't date someone younger than 7 years more than half your age. And we're to write an equation to represent the half plus 7 rule. So I know the wording is a little bit confusing, but see if you can cut through it and figure out how to model this with an equation. Pause the video and try it on your own. We need to start by picking some letters to represent our variables. So we have your age and the lowest age of someone you should date. So I've just chosen to use the letters A and B to represent my two variables. Now we have to come up with an equation. So it says you shouldn't date someone younger than 7 years more than half your age. Well, half your age is A over 2. And the person shouldn't be younger than 7 years more than that. Like this. So the age of the person you are to date shouldn't be more than half your age plus 7. So you can feel free to calculate the age for you. But that brings me to today's lesson. So today we're going to talk about translating English into algebra. So for every English statement that I'm going to show you today, you can turn it into an algebraic expression. So the goal today is to represent situations with algebraic expressions, and we're going to do that in order to solve problems. So let's do some examples. We're going to translate the following phrases into algebra. So first one, the value 5 increased by a number. Okay, so the value 5 is just 5. It increased, so it went up. We added a number. Well, some number. We don't know what it is, so I'll just label it as X. But this right here is an expression that models the statement right here. Let's do another one. Half of a value decreased by 7 is 1. So here's half of a value. The value is X. There's half of it. It decreased by 7. So half of a value decreased by 7 is 1. So now I have an equation that represents the statement. And the last one here, Mario's daily earnings are $80 plus 12% commission on his sales. So I have two variables here, earnings and sales. I'm going to pick some letters to represent those variables. The simplest ones are E for earnings and S for sales, both in dollars. So his earnings are $80 plus 12% commission on his sales. So 12% of his sales would be that. So now I have an equation to represent Mario's daily earnings. Now, if you think back to our analytic geometry unit, we were solving linear systems in order to find the point of intersection between two lines. We can use the same method for solving other problems where we're not necessarily graphing the lines, but basically you just have to remember a linear system is two or more linear equations that are considered at the same time. And the key to remember to any of these problems is if you have two variables, you need two equations to solve. And we can do this using the same methods that we used in Unit 2 to find the point of intersection of two lines. But the hardest part of any of these questions is understanding what's going on. So first you have to read the question. So I'll let you do that. Once you read the question though, go down to the bottom where it's asking you what you're supposed to figure out. The question is, how many hours will Ian have to fly each month so that the cost of renting will be the same as the cost of flying his own plane? So when you look at the question, it's asking you for the number of hours and cost. So those are the variables that we need to solve. And that's how we start these problems. We define our variables. So I'm saying let H represent the number of hours and let C represent the cost. If you don't indicate the units like I did here, number of hours, you have to put it in brackets. So the cost is in dollars. Now that I have my two variables, well, in order to solve, I need two equations. So now I have to hunt through the question and figure out how I can make two equations. He pays $50 per hour for flying time and $300 per month for hangar fees. So that sentence right there deals with the cost. So he has to pay $50 per hour plus an additional $300 every month. So I have one equation already. Now, if he rents the same type of airplane at the local flying club, it would cost him $100 per hour. So unlike owning the plane, he doesn't have to pay a fixed fee of $300 per month. He simply has to pay $100 per hour. So I have an equation representing the cost if he owns the plane and an equation representing the cost if he rents the plane. So now I have my two equations. That is enough to solve for my two unknowns. So back in Unit 2, I had my two equations. I labeled them Equation 1 and Equation 2, and then I proceed to solve. We used the method of substitution. So I substitute Equation 1 into Equation 2 because they're both equal to C, so they're both equal to each other. So 50H plus 300 is equal to 100H. And now I just rearrange my equation to get like terms together, simplify, and solve. So when you do the math, you end up with an answer of 6 hours. Now if we go back up to the question, how many hours will Ian have to fly each month so that the cost of renting will be the same as the cost of flying his own plane? It's really just asking us how many hours. It's not asking us what the cost is. So we're actually done here with our answer of 6 hours. It's not asking us to find what the cost is. So you can finish the question. Therefore, Ian must fly 6 hours for the costs to be the same. Now, you won't be able to do this on a test, but when you're just working on questions, you can use the Desmos graphing calculator to check your work. So if I go to Desmos and I plug in my equations, I can see a nice graph and find the point of intersection is 600. So this would be 6 hours, gives me a cost of $600 for both owning and renting. So I checked my work, I got 6 hours, so I know I got the right answer. Now typically at this point I would give you a group challenge in class. Since you're doing this on your own, you might have to just work on this one by yourself, but if you have someone around you who you want to work on this with, that's fine. So I would recommend you pause the video, try this on your own, and then I will finish the video by showing my solution. So this one, I have two variables, two equations. This one you're not really needing to find the point of intersection because you're just trying to figure out which plan is the better option of using it for 18 hours per month. So if you use it for 18 hours per month, for the first company, you're still just paying $25, but for the second company, you would end up paying $28. So this company is the better option for them because they'll pay less for 18 hours of use. So that one wasn't terribly difficult once you get your equations, but now try the practice questions on your own. So these are the practice questions for today's lesson. They're also listed on your unit outline and the website.